Many moons ago, the wisest of the JavaScript elders came down from the mountain and said, I have created jQuery. And the villagers said, jQuery? The actor from Zombievers. An elder Rezig, for it was he, said, no, it is not a man, it is magic. With these spells we shall tame the capricious browser gods and bend them to our will. And the villagers rejoiced, for the browser gods were indeed capricious and cruel and had visited much misery upon their lands. And they replowed their fields with the new magic, and at the time of the next code harvest, all agreed that the fruits of their labors tasted sweet and Ajaxy. And there were conferences and t-shirts and other assorted merchandise, and that was the end of the first JavaScript era. The tide came and went. The moon rose and fell. Years passed, and while jQuery was still the dominant religion, there were some who grew fearful that it was not powerful enough for the elaborate designs of the modern age. Then one day a traveller came from the western lands of Zuckerbergia and said, hear me, for I bring a message of great import. You're all doing it wrong. These primitive incantations do not befit our modern age of science and technology. Look at these wretched structures you have built. I would not step inside for fear of my safety. In Zuckerbergia, we build not these mud huts, but magnificent towers that reach the very heavens. And we do it not with magic, but with machines. Come, let me show you. And the villagers looked upon the machines, and they liked not what they saw. The traveller was cast out as a heretic. And yet some felt that these machines could perhaps help them meet their own ambitions. And the heretics grew in number until the heresy became the new orthodoxy, and the land was covered in machines. And that was the second era of JavaScript. I'm here today to talk about the third era, the chapter that's being written right now. My name is Rich Harris. I am a graphics editor at the New York Times, and this talk is called Computer, Build Me an App. Now, when I talk about the third era, you probably think that I'm going to talk about using the platform. In recent years, it's become very common to see web performance advocates saying that we should use the platform, which is often interpreted as don't use React. And there's been this rather contentious debate between the two sides, and the trouble is they're both kind of right. They're talking past each other. It can simultaneously be true that abusing frameworks leads to a degraded user experience, while also being true that the DOM APIs are hot garbage. So we have a problem, and I wanted to find a solution. One of the great things about living in New York is that you get to attend Brooklyn JS and the other borough JS meetups. The JS in Brooklyn JS stands for Jed Schmidt, the co-founder of the meetup, and he's a brilliant programmer and an all-around good guy. And one night at Brooklyn Jed Schmidt was explaining his vision of a next-generation user interface framework. And he said something along these lines. The apps we write are directed graphs, but the runtime we have is a tree, the DOM. So writing an app should just be writing a graph, and the compiler would figure out where the dipoles are and rig up the DOM event code to make sure that relationship stays consistent across states. Now, I don't have a computer science background, and to be honest, I was several beers in at the time, so this was just complete gibberish. It meant nothing to me. But one word did stick in my head, compiler. And it led to an epiphany. Frameworks are not tools for organizing your code. Frameworks are tools for organizing your mind. They exist as code, and they often help you write better code, but their true value is in the way they help you structure your thoughts and express them. So what if a framework wasn't a thing that ran in the browser at all? What if it was a compiler? To understand the potential of this idea, we need to understand how frameworks currently work. Before I go on, there's something that I need to make totally clear. I'm going to be criticizing React in this talk, and I need you all to know that it comes from a place of love. React is a wonderful tool. It is part of a pantheon of projects like jQuery, Backbone, D3, and others that haven't just made life easier for the people who use those tools, they've changed the way that our entire community thinks about solving these problems. There is, however, a tendency in our community towards groupthink, and an example of that is the fairly widespread belief that React is the end of web development, that we've reached the pinnacle and there is no further progress to be made, which is what it looks like when you're at a local maximum. This talk is going to be talking about exploring this new unknown territory. Now, the best thing that React did for the front-end community was to popularize the idea of state-driven user interface. And that's in contrast to event-driven. We used to write code like this. We would tell the browser, when something happens, do exactly these things. In the state-driven world, you instead say, this is how I want the user to see, this is what I want the user to see for a given state. And you tell that to the framework, and the framework communicates with the browser on your behalf. This is a very direct and performant way of updating the DOM. But as many of you will know from personal experience, it just doesn't scale. It becomes too complex too quickly, whereas this scales beautifully. The way that it does that, the dominant paradigm today, is the virtual DOM. Whenever your state changes, you re-render your entire application and say, here you are, this is what the user should now see. The framework then compares the virtual DOM with the real DOM and figures out the minimal set of operations that are required to bring the DOM up to date. Now, you will often hear people say that the virtual DOM is faster than the real DOM, which is obviously complete bollocks. It would be clearly much easier for the browser if we could go straight from the first step to the last step. Virtual DOM is pure overhead. The reason that we tolerate it is because of the programming model that it enables. So we should ask ourselves, could we achieve that programming model without all that indirection in the middle? If so, your apps would get leaner and they would get faster. In other words, they would become svelte. Svelte is a real word. I didn't make it up. The Cambridge Dictionary describes it as attractively thin, graceful, and stylish. Merriam-Webster has slender, lithe, sleek, urbane, suave. Over there we have moving and bending with ease. There's also a definition from urbandictionary.com that I quite like. Anything cool, hip, or generally awesome, although that was from 2005, so I have no idea if the kids are still saying that. Nevertheless, I will take it. So how Svelte works is you write your component in an HTML file, the compiler turns it into a data structure called an abstract syntax tree, or AST, and then it generates some code. This is some real code that Svelte generated. And that gives you a normal JavaScript class, like any other, that you can import into your application. You then give it an element to render to and a tree of data, and it goes and does its thing. We now proceed to the live coding portion of the talk. So I'm just writing, bear with me, the demo gods are not on my side. Well, this is annoying. I have a beach ball on my screen. Okay, maybe. Yeah, I don't think so. Okay, so we've replaced the hard-coded data with a variable, and if we open our DevTools, then we can manipulate that data using the component API. Like so. And we can put any JavaScript expression in these tags, so we can do things like that. A really nice thing about using HTML is that You know what, I'm going to try and just do it all on this screen instead. Okay. So a really important thing to note here is this CSS is being interpreted in the context of the component's markup, and so it's able to encapsulate it. It's added this computer-generated class to the element, and it's doing the same thing to the CSS class name down here. And you'll notice that because it's generating a source map, we're able to see exactly where those styles came from. When you're building a big, complex app, it is incredibly useful to be able to know where some CSS came from. And that's something that's often overlooked. It's a huge productivity win. Another thing that we can do by analyzing the CSS in the context of the markup is we can detect unused styles. Sorry, I've just got to get back to the same place. Oh my God, this is not going my way. I'm going to skip ahead to the next slide. We can add event listeners inline on our elements. It might be. I don't know. Okay, I think I might skip some of the next parts of this because it's starting to get a little bit embarrassing. But we can, what I wanted to show you was that we can start to do some nice, slick user interface things, like some really effective custom transitions. All we're doing here is defining some CSS that's generated for a given moment when your when your element is being transitioned into the DOM. And normally with animations and transitions, they're done inside a request animation frame callback, which is less than ideal because that happens inside the main thread and it's often a cause of jank. Svelte takes that and it turns it into a CSS animation behind the scenes, which means that your animations are more performant and they are kinder on your phone's battery, etc. We can also get transitions to talk to each other, in a sense. This is an application where we have some to-dos that have not been done up here, and down here, some to-dos that have been done. And if I click on one of these labels, it'll move it from one side to the other, which is fine, but the human brain doesn't really like that. It doesn't like it when objects disappear and suddenly reappear. It prefers it when objects maintain some sort of sense of constancy. And so we're generating some helper transitions down here with this function called crossfade. And if I add those to my component, this was fine an hour ago. Tell you what, I will tweet out the slides as they are supposed to appear. Let's move on. So an important shift has happened here. In a very real sense, you're not writing the code behind your app. You are writing some instructions, and the browser, the compiler is generating the code for you. Oh no. And this is an important shift because a lot of code is plumbing, and no disrespect to plumbers, but I want to be able to operate at a more creative level. I want to be more like an architect than a plumber. So I like to focus on the difficult creative decisions and leave the boring grunt work to my assistant, the compiler. Now, a question that I get all the time is, why not use JSX? And I'm going to get asked again at this conference if I don't answer it here. So Svelte uses a language called HTMLX, which is a superset of HTML, in contrast to JSX, which is a superset of JavaScript. And the reason for that is that this is a nightmare for a compiler. In HTMLX, this is always going to be a text node, which means that you can compile code accordingly. But in JSX, it could be an element, a component, text. It could be an array of fragments containing all three. And the compiler can't do anything with that. It needs to know what the value of that expression is going to be, which is why we need all of the virtual DOM machinery. Now, having said that, the Facebook team are working hard on this problem. And just yesterday, Dominic Ganaway successfully completed a little experiment to get React server-side rendering in a similar compiled format, and React SSR is now as fast as Svelte. And even though client-side is a much, much harder problem, this is something that you should be very excited about if you're a React user. Nevertheless, I prefer to use HTML-based languages when I'm describing user interfaces because HTML is the language of the web. It means I don't need to worry about all these oddities that JSX presents. And I also feel that using an HTML-based language is more inclusive to the very large numbers of developers who are simply more proficient with HTML and CSS than they are with JavaScript. Now, I'm not the only person who's reached the conclusion that compilers should be the next frameworks. Stencil is a project inspired by Svelte, which leans in on web components. Glimmer is the Ember rendering engine. It does something interesting. It compiles your components to a very efficient bytecode format. Marco is a framework from eBay, which delivers really good performance with some compiler techniques. And Angular is working on a next-generation renderer called Ivy. These are all fantastic frameworks, and you should check them out. A question that I get very often is, surely if your components are being converted into vanilla JavaScript, it's going to be bulkier than if they were just instructions to a framework. And so eventually you're going to reach an inflection point where you would have got a smaller app by just using a regular framework in the first place. And where that inflection point sits is going to differ from framework to framework, but the theory, holds true. But there are some important things to note. First of all, Svelte components actually have a very low incremental cost because the compiler is able to reuse a lot of code. But secondly, in practice, by the time you get to that point, you should be using code splitting anyway. And with code splitting, you just don't reach that inflection point. The thing about code splitting, which is a technique that allows the browser to lazily load assets as and when they're needed, is that if you're using a traditional framework, your smallest chunk is at least as large as the framework and the other dependencies that you're using. And Svelte just simply doesn't have that problem. As it happens, we can solve this problem empirically. Conduit is an application that's part of the Real World project, which is an endeavor to get different frameworks to build the same app to see how they compare at a real use case. It's basically a Medium clone. And according to a recent article by Jacek Shea, it does scale. Svelte is down here in the middle, next to Aprun and Dojo 2. They're the three sort of top performers. This is the initial payload size. This is the reference React implementation, which is much, much larger. It's not entirely fair because this one isn't using code splitting and the Svelte one is, but even if you add up all of the JavaScript assets for that app, the Svelte version is still about 40% the size of the React one. So yes, it definitely does scale, and we can see the effect of that in the startup metrics. The React version starts after about 3 seconds. This is time to first meaningful paint, and the Svelte version comes in at about 1.5 seconds. There's another important metric, which is lines of code. Svelte has about half the number of lines of code that the React version does. And that's not an aberration. That's something that we see all the time, because it turns out that you can express UI concepts much more cleanly and succinctly if you're using a language that is designed for that task. Fewer lines of code is good because it means you can write your apps quicker, but it also means that your apps are more maintainable. There will be fewer bugs. Svelte is reasonably flexible and powerful, but you need something more if you're going to build ambitious apps. And in the React world, we have this fantastic project called Next. The idea behind Next is each page of your app is a component, and when you first visit the app, you get a server-rendered version, and then from there on, you get the client-rendered version, so that the navigation feels instantaneous and native. And so I started thinking, well, could we take the same Svelte philosophy of compilers and static analysis and apply it to that problem? And yes, we can. Where's my mouse gone? So I'm going to create a new Sapper project. Sapper is short for Svelte App Maker. Actually, you know what? I'm going to go to here's one I made earlier, so then we don't need to wait for dependencies to install. And if I build my app, then this is the basic starter template, and you can see as before, we've got the client-side rendering, which is nice and slick. It's very fast. But if we look at the actual markup that you get from the server, it's server rendered, which means that you get that very fast initial load. If I were to build this, then we can have a look at the production stats for this. And you can see that it's less than 7 kilobytes of, I remember you can't see it, it's quite small, but it's less than 7 kilobytes of JavaScript, which is still like more than is necessary, but it's a pretty good start. For reference, if we look at the same app built using Next, then it's well over 200 kilobytes, which is frankly too much for an app that doesn't yet do a great deal. I have some numbers on the server-side rendering performance. So I don't want to get too hung up on the performance stuff. I want to promote the idea that we should be comparing frameworks along other more interesting dimensions, such as, does this framework help me build a more accessible web? I haven't shown you this, but Svelte will warn you if you use things that aren't accessible. Does it help us build slick user interfaces? Does it help us write fewer lines of code? And can we write tools that are more sophisticated than stuff that's based on the command line? I've been very inspired by these two projects, so in my remaining 60 seconds, I am going to try and show you what I've been working on. This is a graphical user interface for building Sapper apps. And you can do some pretty cool stuff if you have tools that are deeply integrated with the frameworks that they serve. I can open an editor and I can go straight to the page that I'm currently on. If I want to look at a particular element and edit that, then I can click the crosshairs button and it'll take me straight to the source code so I can go ahead and edit it, which is a huge productivity win. I've been building apps like this for a short while and it has transformed how quickly I'm able to build stuff. So, in summary, if the first era was the agrarian age in which homesteaders tended to their code bases by hand, and the second era was the industrial age when we started to use machines for everything and people worried a little bit about the pollution, but we can't deny that it had this transformative effect on productivity, then the third age is the information age. The machines are becoming intelligent, and this is the point at which we can stop and say, how can computers help us fulfill our potential as creative professionals? I think this is some very largely unexplored territory. It doesn't just apply to user interface, it also applies to tools and everything else that we work on. So I hope that you will come and explore it with me. And with that, thank you.